All right, we're continuing on from 5.3 day 3 notes using the elimination method when we do not start off with opposite pairs. So if we're looking at number 9 from yesterday's notes, we can see that nothing is ready to cancel out when we get started. So we have to make something cancel out. Yesterday, we did this by only having to multiply one equation by a number in order to create an opposite pair. Today, we are going to have to multiply both equations sometimes in order to make an opposite pair. So the first thing we have to decide is what we want to eliminate. And on problems like number 9, it truly is just whatever you want to do, X or Y. It's not necessarily one's easier than the other. So who wants to pick? Nobody wants to pick X or Y? X. Okay, we'll eliminate X. So we just have to make a decision and go for it. It really doesn't matter what decision you make, but your decision for what you eliminate determines what you do the rest of the problem. Right now, what are the coefficients on X? 5 and 3. We have to choose what we need or want them to be. This is where today gets a little trickier. We need an opposite pair. So we need one positive and one negative. We need them to be the same number. So we have to think about what number could we turn both 5 and 3 into by using some sort of multiplication. Anybody have any ideas? For example, I could turn the 5 into a 10, right? Is it easy to turn 3 into a 10? Using multiplication? No, I'm seeing some people shake their heads no. There's nothing that we can multiply to 3 to make it into a 10. So 10 probably isn't a good option. Emma? 15 would work for us. So you need to have a 15 and a negative 15. It doesn't really matter which one's positive and which one's negative. You kind of just have to choose. If I'm trying to turn my 5 into a 15, what do I need to multiply the top by? I think somebody said it.
3.
A 3. So multiply the top equation by a 3. And if I'm trying to turn my 3 into a negative 15, I'm multiplying the bottom by a negative 5. So this kind of walks us through to where we decide what needs to happen. We need to multiply the top by a 3. We need to multiply the bottom by a negative 5. So once we have a game plan, then we can go forward with it. We'll multiply the top by a 3. We'll multiply the bottom by a negative 5. Before we do that, do we have questions about how we came up with this plan? Okay. So, when I multiply the whole top equation by a 3, I know I have 15x. What about the y? Plus 18y equals negative 6. I multiply the whole bottom equation by a negative 5. So I get my negative 15x. What about in the middle? Negative 25y equals negative times a negative is a positive 20. Questions about multiplying? You're just distributing basically to the whole entire equation. If you forget a part of it, it's going to mess up the next step. So make sure you do it to every piece. If you want to draw little distributing arrows to everything, you could do that, if that helps you remember. From here on out, this is like what we've been doing for like a week now almost. When we combine the x's, they eliminate. That's what we wanted to have happen. 18y minus 25y. Liam? Good. Negative 7y. And then negative 6 combined with 20. Liam? Is 14. We divide and we get that y equals negative 2. Once we have the y, we still need to find the x. So you get to pick where this y gets plugged into. You could plug it into the original top, the change top, original bottom, change bottom. It does not matter to me where you plug it in as long as you do it appropriately. So I'll plug it into the original bottom equation. So 3x plus 5 times negative 2 equals negative 4. 5 times negative 2. Negative 10. Add it on both sides. 3x equals 6. Divide by 3 and we get x equals 2. Our answer should always, always, always be an ordered pair. So it would be 2, negative 2.
What is all of this over there for?
All of this?
Yeah.
That was us talking through our game plan for how to solve the problem. We decided we wanted to eliminate x.
Do we have to put it in what?
No, I'm not grading the notes off to the side. I'm grading the work that you show with the problem. Okay? So this, I think, is just helpful for some people, especially when we just started doing these, to be able to think through the process. Eventually, the goal is for you to be able to think through this all on your own. Questions about number 9? We ready to do another one?
Yeah.
Okay, let's give it a go. So on number 10 and on 11, I went ahead and typed this into the PowerPoint. Again, you do not need to put this on your notes. If it helps you to have it, then that's fine. You can kind of jot it down. So looking at number 10, we don't have any opposite pairs right now. We're going to have to change both equations. We can't make 4 into a 3 or 3 into a 4. We can't really make 6 into a 4 or 4 into a 6. So we know we're going to have to multiply both equations by something. So from the beginning, you decide what you want to eliminate. Now on this one, in my opinion, there is one option that's just a teeny tiny bit better than the other. And that would be to eliminate y. Can anybody think of why? I might say y is just a teeny tiny bit better in this problem.
Because
they're both divisible by 2.
That's not why I was thinking. That might be a okay reason. What are the coefficients on the y's right now? 4 and what? Okay, 4 and negative 6. If I'm trying to make an opposite pair, I need one of my numbers to be positive and I need my other number to be negative. So right away, I already have the positive negative set up that I need. If I were to use the x's, I would have to change the signs on one. And that would be fine, but some people don't always remember their rules about multiplying by a negative. So I like the fact that one of these is positive and one of them is negative. Questions?
I thought it was supposed to be the same number.
Yes, on what we want the coefficients to be on the next line, yes, that's where we should have the same number. So, what number do you think we want to make these into?
Positive 6. Nope, 12.
12 and
Negative
-12.
12.
You have options. You could have used like 24 and -24. You could have. It's easier if you keep your numbers smaller. And we know that both 4 and 6 will divide into 12. Okay, so again, there's not just one correct way to do this. There are multiple ways of doing these problems. I'm just going with what I think is the easiest way. If I'm trying to make this 4 into a 12, I will multiply the top equation by 3. If I'm trying to make -6 into -12, I will multiply the bottom equation by 2. Okay, so I will multiply the top equation by 3. I'm going to write that. Parentheses with a 3. I will multiply the bottom equation by 2. I'm going to write that. So now we multiply through to every single piece. So my top equation becomes 12x plus 12y equals 48. My bottom equation, I'm multiplying everything by a 2. So 6x minus 12y equals 6. I like multiplying by positives because then I don't have to worry about what signs are changing. Questions about getting to this part of it? Once you get here, everybody in here should be able, at this point, to be able to do the rest of the problem. From here, this is like what we've been doing for a week. We combine, our y's eliminate. We get 18x equals 54. To get x all alone, we need to do what? Divide by 18. And we would get x equals 3. Questions about getting x? Now that we have x, we still need to find y. So we're going to take that 3, and you have 4 options now of where to plug it in. One of the original ones, one of the ones you changed. You get to choose. I'm going to go back to the top original. Any one that you choose, it should come out the same. 4 times 3 is 12. To get y alone, what do we need to do with that 12? Subtract it on both sides. 4y equals 4. We divide and we get y equals 1. Our answer is 3, 1. Questions about number 10? All right, we'll move on to number 11. Again, on number 11, we can see pretty quickly nothing is set up to cancel out right now. We have to decide what we want to eliminate. No matter which one we choose, x or y, we already are set up with one positive and one negative. So here it truly is up to you. What do you want to eliminate?
The y's.
Okay. If you were to choose x here, that would be fine. There's a whole completely different way to do the problem where we get rid of x first. We're just making a decision. I want to eliminate y. The coefficients right now are -3 and 5. We have to think about what we want the coefficients to become.
15 and -15.
Okay. I am going to write the -15 first because the 3 was already negative.
Okay.
Okay, and then I'll put my positive one back here. We do need one of them positive, one of them negative. So I will multiply the top equation by
5.
a 5 to make -3 into -15. I will multiply the bottom equation by
3.
a 3. So I'll write that up here. I'm multiplying the top one by a 5, multiplying the bottom one by a 3. Are we ready to execute this plan?
Yeah.
All right, when we multiply the whole top one by a 5,
-15. Wait, no.
negative 10x.
Negative.
Yep, the -15y that we planned on, and then equals -35. The bottom one, we multiply everything by a 3.
Wait, we have to multiply the bottom the same way. I thought we only have to do like one problem, one equation that we change.
Yesterday, we only changed one equation. Today, what's different is that we're changing both of them.
Okay.
Okay, so that's why we wrote out this plan, or I wrote out the plan. I'll multiply the top one by a 5, I'll multiply the bottom one by a 3. 9x plus the 15y equals 36. When we combine the y's eliminate, that's what we wanted. We planned on that.
-1x.
-1x equals
-1. No, 1.
+1, and then we divide
By -1.
x equals
-1.
a -1. Once we have the x, we still need to find y. You get to choose where that gets plugged back in.
Top one.
The original top one?
Mm-hmm.
Okay. It doesn't matter to me. Oop, it's got to go for x, though. All the way over here for
so when
x.
you plug it in, you don't plug it into the new equations you plug
You
in?
can if you want to. I always like to use the original one because the numbers are usually smaller. But if you really want to use your top one from after you changed it, that's fine. Your numbers will just be a little bigger. I gotta write a little smaller, so I'm running out of space. Okay, -2 times -1 is a +2.
Yeah,
Subtract 2, -7 minus 2.
wait, I thought you were supposed to plug it in for. Okay.
We got x, so we plugged it in for x.
Oh, never mind. I'm thinking I put it in for y.
Oh, gotcha. All right, so we're at -7 minus 2. -9. And then we divide by that -3. We get y equals a +3. So as an ordered pair, our answer is -1, comma 3. Questions, concerns, warm fuzzy feelings?
Can we not do this for a problem?
We will not do it right now. I'm not going to promise that we're never going to do. We won't do the word problem right now
Today.
because I want you to practice these basic skills before we go back to word problems. Okay, I will leave this example up there, especially for those of you that didn't write these words steps off to the side.